Okay, this is part 2 of 8.7. We're dealing with polar coordinates, polar graphs, and polar equations. So we've already played in part 1 with polar coordinates, how to change rectangular coordinates to polar and how to change polar to rectangular. Now let's talk a little bit about polar equations. Alright, so polar versus rectangular equations. So if you have an equation that deals with x and y, well then that's rectangular. Whereas if you have an equation in r and theta, then you're dealing with something polar. I wrote down our 4 little equations that allow us to translate between polar and rectangular over here on the margin. X equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and tangent theta equals y over x. I'm going to keep this as reference because we're going to be using them. Okay, so let's look at some examples of rectangular and polar equations. So here I have an equation that's rectangular, x squared plus y squared equals 16. This equation, the graph represents a circle centered at the origin with radius 4. Now, it's not a difficult task to change this rectangular equation to polar form. All we have to do is recognize that x squared plus y squared, that is r squared. So I changed the left-hand side of this equation, x squared plus y squared, to just r squared, because that's what r squared is. So r squared equals 16. And then in order to really get my polar equations, I would say that r is equal to 4 and r is equal to negative 4. Yeah? So I put a little warning here. Always solve for r whenever you're changing a rectangular equation to a polar. So always solve for r. And also with polar equations, so we're used to, in rectangular equations, we're used to x being the independent variable, y being the dependent variable. In polar equations, we gotta think of r is the dependent variable, so r is kind of like my y, and theta is going to be the independent variable, sort of like my x. So think of r as the dependent variable and think of theta as the independent variable. Yeah? Okay, so here I have another example. It's I have a rectangular equation, y equals x minus 3. That just represents a line with the y-intercept of negative 3 and slope 1. I can change this equation to its corresponding polar form. And its corresponding polar form is r equals 3 over cosine theta minus sine theta. How did I make this change happen? Well, what I did is I looked at my little equations over here, and I know that x is supposed to be equal to r cosine theta. I know that y is supposed to be equal to r sine theta. Well, in this equation over here, I changed y to r sine theta, and I changed x to r cosine theta. And then what I did is I solved for r. And I ended up with this equation. That's how I know that this is the corresponding polar equation. Remember, if you're ever going to get a polar equation, always solve for r. Okay, so it's your turn now. What I want you to do is I want you to convert this rectangular equation to polar and then make a little sketch of the graph. So pause the video, take a couple of minutes, see if you can come up with the polar equation here. Alright, so hopefully you were able to come up with the polar equation and the graph. So now let's just compare answers. So I am going to use my 4 little translating equations that we have up here. Change my x to r cosine theta, change my y to r sine theta, and then solve for r. So this is going to say r sine theta is equal to 2 times r cosine theta minus 5. Okay, so that's r sine theta 2r cosine theta minus 5. Now how do I solve for r? I have r on the left hand side of this equation, I have r on the right hand side of this equation. Well, maybe it would be a good idea to first get r on the same side of the equation. I'm going to put all of my r's on the left hand side. Okay, so now I have r on the left hand side of this equation. I have two terms that involve r. So what do you suppose is the next thing that we should do? Maybe let's factor out an r from the left hand side? Yeah, that's what I'm going to do. Okay, and now in order to solve for r, all I have to do is divide. So I'm going to say that r is equal to -5 divided by sine theta minus 2 cosine theta. And that's it. That is the polar equation for this, that corresponds to this rectangular equation. Now the graph is easy. At this point we should be able to graph these things no problem. This is just a line that has a y-intercept at -5, and it has an x-intercept. It hits the x-axis at 5/2. How did I find the x-intercept? I set my y equal to 0 and solve for x. If you set your y equal to 0 and solve for x, you'll discover that it hits the x-axis at 5/2. Okay, and so then my graph is just a line that happens to go through these 2 points. So that's the graph of my equation. I mean, I think the polar form of this equation is maybe a little bit complicated, but it's not too bad. So hopefully we got the same answer and you agree with the answer here. All right, next thing. This is your turn again. You gotta convert some polar equations. Let's convert some polar equations to rectangular equations. So let's begin with these two. So begin from changing this polar equation to rectangular equations. Pause the video, give yourself a few minutes to try to change things to rectangular. Okay, so hopefully you've gotten a chance to try this on your own. Let's see. Let me begin changing the first one to a rectangular equation. First, let me rewrite it. I'm going to say r is equal to -5 times 1 over sine theta. Yeah? Because that's what cosecant is. It's 1 over sine. Alright, and now I'm going to multiply both sides by sine of theta. I hope that you agree with what I did there. I just multiply both sides by sine of theta. Now, you should realize that this r sine theta business here, that's just y. Right? Because we know that y is equal to r sine theta. And so then my equation is just y equals -5. And that's it. We have our rectangular equation. This is just a horizontal line. Just a horizontal line that hits the y-axis at -5. Alright. Let's think about the next one. So, some similar procedure. I am going to begin by multiplying both sides by this denominator. I'm going to multiply both sides by this denominator. So if I do that, I'm going to end up with the following. R times 4 cosine theta minus sine theta, and all of that is equal to 3. I'm going to distribute the r now. I have the hardest time writing r's, I don't know why, and 4's. Okay. And now you should realize here that r cosine theta, that's just x, and r sine theta is just y. So I'm going to say that this becomes 4x minus y, and that's it. That is my rectangular equation. The only thing that I'm going to do here is I'm going to solve for y so that it becomes a little bit more obvious. And well, if I solve for y, I have the following. So that is my rectangular equation. Then now I'm just dealing with some type of line. So, okay. The last one. The last one is maybe a little bit more cumbersome. Again, try to pause the video and give yourself the chance to try it. Just pause the video, see if you can solve it on your own. Alright, so let's see. I'm going to begin kind of by doing the same trick that I've done before in the other ones. I'm going to multiply both sides of this equation by 1 minus sine theta. And if I do that, I end up with this. Now let me distribute r. Okay, and now you should realize that r sine theta, we can replace that with y. But what about r? What about r? I mean, I know that, let's see, I'll put it over here on there. I know that r squared is equal to x squared plus y squared. I know that, but what about just r? Well, I hope that you agree, since it's positive, it's just the positive square root. So this becomes square root of x squared plus y squared minus y equals 3. Why did I choose the positive square root? Well, because my r is positive right here. If it had been a negative, then I would have put a negative outside of my square root. Alright, so that is it. That's my rectangular equation right there. The only thing is I want to solve for y. Just to kind of make it a little bit more obvious. So what I'm going to do in order to solve for y is I am going to, well, try to get rid of this square root. I'm going to square both sides. Oops, not to the 9th, squared. Okay, so then that becomes x squared plus y squared is equal to y squared plus 6y plus 9. And then if I subtract y squared from both sides, I end up with the following. X squared is equal to 6. Let me give myself a little bit more room here. X squared is equal to 6y plus 9. Which means that if I solve for y now, it becomes this 1/6 x squared minus 9 equals y. So I think that's a much more recognizable rectangular equation. Right now we're just dealing with a parabola. It's a parabola that's been shifted 9 units to the right, and it's been vertically compressed. Okay, so hopefully we agree here on the computation on how to change these polar equations to rectangular ones. Last thing in this in 8.7, let's graph some polar equations. And one thing I want to make you aware of is that your calculator, your TI-83, 84, whatever it might be, has what's called a polar mode. So if you go to mode, you'll see that you have you have the degree and radian option, and then you have a couple of menus down. You have right now what's it should be highlighted as FUNC. It's in function notation, but then you also have POL, polar. You have parametric, param, and then you might have differential equations. So you have several options here. And so if you were to change your calculator from function to polar, and then you go to your graphing utility, if you go to your little graphing, what you're used to, how you graph things in your calculator, you should see that now it says r of theta instead of y equals. Yeah, and so then you could just enter this 2 minus cosine theta into your calculator and look at the graph. I encourage you to do that. You should try that so that you can sort of just double check your work. So we're going to graph this polar equation by hand. We're going to do it the old-fashioned way, just by hand, and then hopefully you'll play with your calculator in polar mode and just make these graphs happen a little bit quicker. Oops, sorry. Okay, so let's see. I want to graph 2 minus cosine theta. So what I'm going to do, remember, we got to think of theta as the independent variable. It's kind of like my x. And r is the dependent variable, kind of like the y. So I made some choices for theta: 0, 30 degrees, 45, 60, 90, 120, 135, 150, 180. And I'm going to plug in those values into my polar equation. I'm going to replace theta with 0, 30, 45, and I'm going to see what the corresponding r is. Alright, so if my theta is equal to 0, I have 2 minus cosine 0. Well, that's 2 minus 1, so that's 1. So I've generated 1 point. 1, 0 degrees. That's a polar point right there. Alright, so I continue like this for the values of theta that I chose. So 2 minus cosine 30, that's the same thing as saying 2 minus root 3 over 2. That's about 1.13. So then I have the point 1.13, 30 degrees. Then 2 minus cosine 45, that's 2 minus root 2 over 2, that's about 1.3, 1.3, 45 degrees. And so on and so forth. I continue like this, plugging in, for instance, here I would say 2 minus cosine of 90 degrees. Well, cosine of 90 degrees is 0, so 2 minus 0 is 2, so I have the coordinate 2, 90 degrees, all the way to 3, 180. So I'm just making here a table of values to generate polar points. Yeah? Now let me graph this. Let me put all of this in a graph. So I'm going to begin with 1. I'm going to begin by graphing 1, 0 degrees. Okay. So how do I graph 1, 0 degrees? So I'm going to go, I'm going to go 1. I'm going to begin at the pole. I'm going to go 1, radius 1, and then 0 degrees. So I don't rotate anywhere. I just stay right there. So that's my first point. That's the point 1, 0 degrees. Now let me plot the point 1.13, 30 degrees. Alright, so I gotta go from the pole to 1.13. Well, that's kind of, I'm thinking that this is 1 and this is 2 right here. Yeah? So the first concentric circle is 1, the second is 2. So 1.3 is, well, kind of close here. And then I have to go 30 degrees. All right, so that should put me, I don't know, I'll try to sketch it as best as I can, somewhere around there. Yeah, a little bit, it's at 30 degrees. So I have plotted this point right here, 1.1330 degrees. Now let me go to 1.345 degrees. So 1.3 first, 1.3 somewhere around here, and then 45 degrees. That puts me right there. So let's say, I don't know, something like that. So that's my point. That's 1.345, and then 1.5, 60 degrees. So 1.5, 60 degrees, that should be right there in the middle. That's 1.5, 60 degrees to 90 degrees. All right, so that one is easy. So I go 1, 2, and then 90 degrees. So that's right there. 2.5, 120. So 2.5 and 120. All right, so I'm right here. That's 2.5, 120, and then 2.7, 135 degrees. So 2.7, and then I have to go to 135. All right, so a little, I don't know, somewhere like right there, we'll say. So I've plotted this point. Now 2.8, 150 degrees. So 2.8, 150. So that's getting close to kind of 3. So we'll make the best we can here. Somewhere right there. And the last one, 3, 180 degrees. So I go 3, 1, 2, 3, and then 180. All right. So far, that's how many points of, that's about 9 points right there. I would need probably another 9 points to sort of see the whole picture here. But if you, I encourage you to put your calculator in polar mode and then just enter into your graphing utility 2 minus cosine theta. And you should see that this little graph looks something like this. Let me sort of fill in the dots here. It's supposed to look something like that. It's like a little egg. This is a horrible little sketch. I'm really bad at writing on my computer screen, but you get the idea. Yeah. And that is it for graphing polar equations. I mean, it's kind of tedious to do it this way, but definitely be aware that your calculator can be put in polar mode and you can enter and you can get really cool sketches of weird little graphs. You can get these cool little spirals and cardioids and all sorts of things. All right, so it's your turn now. You should graph this equation, 4 sine of 2 theta. And in your notes, you are provided with a little table, sort of like this. Fill it out, go through the process, generate the points, plot the points by hand, and then see what sort of sketch you come up with. And if you want to just kind of verify your work, just use your calculator. Put your calculator in polar form and graph it. And if you graph this 4 sine of 2 theta, what you end up with is this kind of little spiral thing. Yeah? So hopefully you agree with that. And that is it for this section. That is it for 8.7. We've dealt with some polar equations and polar graphs and changing back and forth between polar and rectangular. Okay, thank you. I'll see you in the next video.